The recent labs contained so much information that I've decided to put some cheat sheet to kind of memorize all those things. So first of all, the most important fact is that within OSPF, within the area, the LSAs are flooded everywhere. So every router has to have exact same information in their link state database as to what the destinations are. That's why we're limited in terms of how we can prevent uh, certain prefixes from being used by the router. And for that, we use distribute list command with some matching mechanism, such as prefix list, access list, or route map containing one of those. And what it does, it prevents the prefixes from being installed into routing information base or routing table. Alternatively, we can apply a distance value 255, which is unknown distance, and that prevents the router from installing those into the routing table. And this is the only way we can do some filtering within the area, and still the link state database will be identical on all routers. We only prevent installation of certain prefixes into the routing table. For the inter-area communication, we use summarization commands, uh, such as on ABR we can use area number range command matching certain particular prefix and use the keyword not advertised, and that it'll stop basically ABR from passing information about LSA type 3 into some other areas. ASBR, Autonomous System Boundary Router, does the same thing, the same job, only for external prefixes LSA type 5. We can use a summary address command plus not advertise, so we do summary address, for example, 10.1.1.0, 255.255.255.0, not advertise, and that one will not be installed into the routing table. But those are referred to LSA type 5 only on ASBR. Proper filtering is applied using different types of areas. So we have area normal, which allows all LSAs to enter the area, or we can use area stub, and the flag must match on all routers within the area. And if particular area is stub, what is happening? The ABR does not forward or advertise type 5 LSAs, and 4 obviously, which is the reachability to ASBR, and instead it presents itself as the gateway of last resort. It installs the default route into all other areas that are stub. This is going to be LSA type 3. Cisco also added a totally stubby area, which the command area stub no hyphen summary will be installed only on ABR. On other routers, we only have area number stub. This prevents the router from advertising LSA type 3, 4, and 5. Instead, it installs default route into those routers. Some situations call for stub area, which means that certain prefixes won't be installed, for example, LSA type 5, but we need to have a presence of ASBR in that area. So this is probably corner case scenarios where we filtered something out, but we still need to introduce external prefixes. This is where not so stubby area comes into play. So stub area allows a presence of ASBR, which introduces external prefixes as LSA type 7. ABR does not install default route by default. So if I want my ABR to be a gateway of last resort, I need to add the command default information originated to this area stub no summary. This one is going to be filtering out LSA type 4 and 5 into NSA, but will still advertise LSA type 7. However, ABR, while introducing LSA type 7 into area 0, it will introduce or translate them into LSA type 5. And finally, this totally not so stubby area, or totally not stubby area, is the one that allows the same presence of ASBR in area where we filtered LSA type 3, 4, and 5. So it by default in ABR installs a default route or presents itself as a gateway of last resort as LSA type 3, and still advertises LSA type 7 into the backbone or area 0 as LSA type 5. And the last thing is the OSPF selection order. So if the router is presented with multiple options towards certain destinations, it is going to use this in this particular order. The router prefers intra-area routes over anything. And if there's also inter-area routes and that there's no presence of intra-area, that's the next one in turn that is going to be used. Then it prefers external type 1, the ones that increment the metric while the advertisements are passed from router to router, over the external type 2, which uses the default metric on all routers, which is always 20 by default. And finally, we have NSSA type 1. Again, this one increments the metric value as the advertisements are passed from router to router. And here's a typo. And NSA type 2, which are presented as type 2 here, is going to be the last resort. Finally, there's a default route, obviously, if nothing else is given as the destination. And what note is this order cannot be changed with the metric or distance manipulation. So if I change the metric, still this order takes precedence over any metric at all.